I think we're live.
Yeah, let's see. We have an ad. Just a second. Okay. I guess we are live. Let me know if I'm audible. Let me know if I'm audible.
Yeah. You are audible here,
Okay.
but I also want to know if I'm audible.
Those who are joining, let us know like if both of us are audible now.
Yes, I think we are audible.
Yeah, we
I
are. We
checked.
are audible. So let's. So as usual.
Let's wait for some time.
Yeah. Let's
Let's wait
wait
for some
for a little bit, and till then I can give my introduction a little bit, and it's revenge time. So
It's revenge, yes.
so let's see what we can do. What questions? Like I have picked up couple of questions for Soham as well, and I am trying to stop him from solving both of them, and that will mean I have won because I have solved both. But let's see what's happening. Like what will happen, God knows. So before starting, let me quickly introduce about myself. I'm Subash Singha. I'm a competitive programmer. I'm also working as a software developer engineer in one of the top tech companies. I'm also educated in Unacademy, and I think a short intro is enough. Let's quickly meet our guest today. He's Soham. I just have given an interview with him. And Soham, can you quickly introduce about yourself?
Sure. So, hi everyone. I'm Soham Mukherjee. I am a software developer at Google. I've worked with Coordination before that for 1 year, and yes, I have already taken interview of Subash. He did well, but again, like I'm worried that I might not do well, so I don't want to lose this one. But let's see what happens. I understand that he has some revenge material within him. Let's see what how it goes.
Okay. So Soham, I have shared a sheet with you. Can you open the sheet? It's given there. Like I've shared a sheet, and
Sure.
can you please write hello or something right like there, so that we know that you have the
Sure.
access.
Hello.
Okay, so I can see that you have written. Let me increase the font. Uh, and yeah, let's increase the font a little bit so that it's audible, like it's visible. Yeah, so it's visible. So welcome all, welcome all. So if anyone is new here, we are doing a interview duel. I have already given an interview to Soham where he has asked me two questions and I was able to solve both of them. And now it's revenge time. It's time for Soham to solve the question, and I'll be giving him couple of questions. One will be easy and one will be a medium hard problem. Let's see if he is able to solve both of them. And without further ado, let me quickly bring the questions here. So people here can also try to solve them, but please don't write it on the chat. I want Soham to solve it all by himself. So Soham, here is your
Okay.
first question. It is a little bit on the easier side. So you will be given a string S such that each character is either 1, 2 or 3. So you will be given a string and the characters there will be either 1, 2 or 3, right? You have to
Okay.
choose the shortest contiguous substring of S. So you have to choose a substring and that has to be as small as possible such that it contains each of these three characters at least once. So whatever substring you choose, either 1, 2 or 3, each of them should be present at least once, and the length of the substring should also be shortest. So are you getting the
Okay.
question?
Yes, I think I've understood the question. So
Let
let me
me
just
yeah, let
yes,
me
you can
let me
add some
share
questions.
let me share some example with you and also the answers. So this is the example, right? So you will be given initially a test case. So for
Mm-hmm.
test case will be like how many inputs you get, right?
Okay.
And for each input you will be getting some string with characters 1, 2 or 3, right? So you can see the
Mm-hmm.
characters will be nothing other than 1, 2 or 3, right? Now you have to
Right. Right.
find the shortest substring such that you have to find the shortest substring such that each characters come at least once. So for the first one it's very inevitable, like the size is 3, because if you pick 3 you get all the answer as 1. So the first answer is 3.
Mm-hmm.
For the second
Okay.
answer also you can see that there is a substring of size 3 which has all the 3 distinct characters at least once,
R-
right?
right.
Yeah. So 3 for the second also. But for the third case, if you see, there is no way to have 3 as answer, right? So you have to
Four
pick
will be
at
the answer.
least 4.
Yes.
At least 4, right? If you pick up this
Mhm.
also, it becomes 5, but this is the possible answer, right? So
Right.
you have to pick 4. 4 is your answer here. So this is
Mhm.
my first question to you. I know it is a little bit easy on the easier side, but don't worry, I have a hard problem for you as well. So yeah,
Okay. Yeah.
you can start.
I I'm really waiting for the hard problem, but yeah, I do have a solution for this. Although I'll try to maybe optimize that more. But I'm not going over the like, maybe just discuss the brute force. So brute force would be like just generate all possible substrings, and then in like for every substring, as we like generate the substrings, we can maintain a running count as well. Like what is the number of ones, twos we have got, and that way we can easily answer in n squared, although I'm pretty sure that that's not what you're looking for.
Yeah,
So
obviously.
let's let's just jump to the solution. I think I have one. So see, what I see here is that let's say I fix a length, right? I'll maybe define a function p, which will be a predicate function, let's say. So p of x, what does this mean? That given x, right? So I'll just write the meaning for this. Like given a length x, is there a substring with of length x with all distinct characters? So with all distinct character, not distinct characters, sorry, with all three characters, right? All three characters. So I'm defining a p predicate function which takes an argument x, right? What does it tell? It tells that if I am given a length x, can I get a substring that has all the three characters available?
Okay.
So what will I do is now, first of all, let's just think about what can we do with this, right? So all the three characters are available. So as if we see like to prove that binary search, like I am thinking about binary search here, but I have to prove why will binary search actually work, right? So to prove that binary search actually works, we have to like have some like reduce it to some similar problem. So let's say px returns true or false, like it definitely will return true or false by the definition. So what will this array look like, right? So let's say initially it will be false, like when if you have one character x is 1, so can you have a substring of length 1 with all unique characters? No, right?
No.
So let's say it will be false. For 2 also it will be false. For 3 it might be true or false. Let's say it's false, like let's just consider the last example, right?
Okay.
For 3 it will be false. For 4 it will be true. And once it becomes true, you can always find a substring of greater length that contains all the characters, all the three characters. Basically, you just take that substring, like let's consider this example 1123. You just take this substring of length 4, you get all the characters 123. You can get a substring of length 5 as well that contains all of them, right? Like just to take one more 1 and or one more 3, both of them work. Similarly, you can get 6 as well. So
Yes.
it will always remain to be true after this, right?
Yes,
So
yes.
that means we have a array. Will basically this predicate array, if it is created, it will be something like this. So definitely we can do a binary search, right? Binary search, because it's kind of 0 1, it's kind of a monotonic function that is getting created here. So we can binary search for the first occurrence of true. That is what we need, the first occurrence of true. That is first place where given x, the substring has all the three characters present. So we want this first occurrence of true.
Yes.
That's what we reduce our problem to. Now, definitely we can go for a binary search here, but coming to this part, how can we quickly solve this part? Like definitely we cannot spend a lot of complexity on calculating this predicate, right? So what we can do is, we are given a length x, right? We are fixing a length x here. What we can do is, we can assume this to be a window, right? We can assume this x to be a window, like the window size is x. So we'll move this window across the entire string. We'll just move this window across the entire string and check with what we'll maintain is, we'll also maintain a frequency, whether how many a's are there, how many b's are, sorry, how many ones are there, how many twos are there, how many threes are there. We'll maintain a running frequency for across all over all the windows. Okay. So we'll use a sliding window like approach, and we'll calculate like if there is a substring that contains the frequency of each 1, 2 and 3 to be greater than 0. If that's there, we'll just return true, otherwise we'll return false. Yes. So that's the idea that I'm getting. I'm not sure, like I think we can also do it using 2 pointer in order of n, but I'll just write a log in solution for now. because I'm tensed about the hard problem right now.
Yeah, no issue.
So
Like your
in
your problem seems pretty much correct to me. Like well thought about the binary search, like changing it to a
uh-huh.
different question altogether. Yeah, you can code it
Mhm.
out. I got your solution. Like you are basically doing binary search, and after that, to find that whether your constraint is true, like whether to move on the left hand side, on the right hand side, you are doing a sliding window technique, right?
Right. Yes.
Okay, cool.
Okay. So yeah, I'll just write some code maybe. Obviously it will be what? It will be integer int mean uh, mean length mean substring with all characters. Let's call it mean substring with all characters. We'll take in a string as input. So string. I'll take a reference for of the string here. Okay. Let's try to write the code for this. What will it contain? Uh, Definitely. I'll definitely like what is low. Because when we are doing binary search, we need a low and high, right? So low will be, let's say low is can low be zero? Okay. Firstly, when I do binary search like this, when I do a binary search on an array like false, false, and then after that true, I generally tend to do it in a way that I'll always keep my low to a false and I'll always keep my high to a true, right?
Yes.
And in that, when I get the mid, I can decide if mid is greater than if mid is true, then I can move my high to mid. If mid is false, I can move my low to mid, right? In that way, like it actually makes things a bit easier. So I'll just write that similar code. So low will be one definitely. High will be let's say high will be h dot size or h dot length. Both of them work,
Yeah, sure.
right? And let me write here. So low is this, high is this. Now let's create the let's create the predicate function here. So bool p, it will be a bool predicate function. It will take in x and it will take in the string s as well. So string, it will take a reference to the x and it will return uh, x is and return get minimum substring. Uh, it will return what we can do here. Let's just write it here itself. So int, what we'll do here, we'll maintain a frequency. We'll have three elements. So frequency of 3. Initially everything will be 0. So I'll just set this to be 0. Now I'm going for a sliding window. So first of all, I'll take the first window of length x. So for int I equals to 0, I less than x, I plus plus. I'm taking the first window of length x, and what I'll do is I'll do frequency of int of s of I minus 1, just to like map them to an integer of in the range 0 to 3.
Okay.
Minus 0, let me do it minus 1, 0 to 2, it will
0
be
to 2
mapped
it will
to
come. Yeah.
plus equals to 1, plus equals to 1. Okay, frequency of this will be plus equals to 1. Now I'll add a checker function here. Maybe I'll add a checker function here. Bool is available, is all available. That will take a frequency array. That will take the frequency array, and it will just tell me whether it's like all of them are true or not, like all of them are greater than 0 or not. So if for let's write it like, let's write a for loop only. For int I equals to 0, I less than 3, I plus plus, I plus plus, if I'll just maybe indent one more. Okay, so if frequency of I is greater than 0, is equals to 0, that means it is one of them is not available. I'll just return false, otherwise I'll return true. Okay, now coming to this part, frequency in test of I plus 1. Okay, now I'll add a check here. If, let me just copy the method name, is all available. I'll just take this. If is all available of frequency, then I'll just return true. Otherwise, I'll go for a sliding window. So for int I equals to x, I less than s dot size, I plus plus, and let's see, I less than s dot size, I plus plus, and I'll just see if what if I'll just add and subtract definitely.
Yeah,
Frequency of int s of I, it's coming here. I is coming right now. So s of I minus 1, it should be s of I minus 1, it should be plus equals to 1. And what is going away? Let me just copy this. What is going away? I minus x is going away. Like when I is at x, 0 will be going away. Like we're considering the sub array 1 to x, right? So 0 will be going away. So I minus x.
Yes, y
That's
minus
going
x will
away.
be moving back. Yeah, will be
Yeah, in out of the window, right? So this, and we'll check here if definitely if is all available. We just have this statement here,
Yeah, sure.
right? If we get this, sorry, if we get this here, then we should return true. Otherwise, if we don't get a true, we'll just return false. That is not available. Like not, we cannot form a substring of this length that will like contain all the distinct characters, right?
Makes
so
sense.
we have this now. First thing to check here, definitely one will be false. First thing to check here, if high is true, right? So if what did I call this? I made this a predicate function p, right? So if p high should be true, I and s, if I pass this, and if it is false, then I should return like answer is not possible. So I should maybe return minus 1.
Yep.
Right. Otherwise, I'll just do the binary search. So while low less than high minus 1, because here we'll do this binary search a bit differently, because I'll explain this later once I'm done with the code. So if we'll find the mid as low plus high by 2, low plus high divided by 2, and if definitely if p of mid s, if it is true, then high equals to mid, else low equals to mid, and our answer will be high. So return true. So this, return high. Sorry, my bad. Yes, our answer will be high. So basically, what I'm doing here is we are binary searching on an array that's true and false, right? So it's like false, false, false. Let's say it's true here, and after this it is true. So when we are actually going to, like, when it is actually, where will it end? We'll always make our low point to a false, and we'll always make our high point to a true. So it should ideally end here. If it has to end somewhere, it will ideally end here, because our low will point to a false, high will point to a true. It should end here. So that's why I have the condition low less than high minus 1. Now, if at mid, let's say first iteration, mid will be, I think, this one. This one will be the mid, so it is false. So my now search space, my low will come here, right, at this one. So my search space has reduced to this thing. Now again, in the next iteration, this is the mid, so high will come here, and this is my search space, and here it will terminate, and it indeed gives me the answer, right?
Okay,
this is the first occurrence of true.
So anyhow you do it, always the answer ends out on the high, and that you are returning.
Right. Yes.
Makes sense. So yeah, so can we quickly discuss the time complexity here? What can be the time complexity?
Sure. Sure. So okay. So the time complexity will be like, this loop is running for login time.
Yes.
Now for each of these iterations, I have this p that's doing something, right?
Yeah.
So if I go to this p, what is the complexity for this p? So it's login into complexity of p, because this is running for login iterations, and each iteration we are calling p. So login into complexity of p. Now complexity of p, if we see, we have done a sliding window, so it's like order of n time it's taking. First of all x, and then x to n, so it's order of n time. N is the length of the string. So total complexity for each iteration of this binary search, it's order of n. So total of order of n log n is the complexity.
Makes sense. So yeah, you have got the perfect solution. I was also expecting a solution for n log n, and you have done it perfectly. So anyone has any doubt in this question, or can we move in the second question? Like we have ample of time, so I was able to solve it very quickly.
I have a hard problem.
Yeah, let's quickly jump to the second one, and we can get we can discuss the solution at the end. So this is the second question which I have got for you. Like, I am fond of bikes, so I have formulated a question related to bikes. So you can go through this question once, and I asked my viewers also to go through this question and try to understand like what can be the question here, right? Like what can be the solution here. Don't write it in the chat. Let Soham solve it. So the question is that you went to a certain state, and in that state you have n cities, and you are given total n number of cities, right? and you have m
Right.
roads that are connecting these cities. So you can expect that will be a connected graph. So if n cities
Mm-hmm.
and that is connected by m roads. Now you want to travel from city 1 to city n, right? You want to
Okay.
travel from city 1 to city n, and there are two traveling options from going from one city to another. One is you use a
Uh-huh.
super bike or you use a normal bike, right? So
Okay.
for each road, time taken to travel from normal bike and super bike is given. So for each connections, you have two values. One value is what will be the time if you take normal bike, and for one more,
Mm-hmm.
what will be the time if you take a super bike. And
Okay.
after that, you have to calculate what is the minimum time required to reach city N if you can take super bike at max once.
Oh, okay. At max once.
Yes, you can take.
I just
Yeah,
I
yeah.
just thought maybe just replace everything with the speed of the super bike or whichever is the
Yeah,
minimum.
yeah. So
But yeah,
super
that's
bike obviously will be like, I cannot assure you that super bike will be always smaller, but in most of the cases the time taken by super bike will be less than normal bike. But you can use super bike at max once. You are not allowed to use it two three
okay.
times. You can choose not to choose also, like at max once, right?
All
So
right. Uh-huh.
yeah, so your question boils down something like this, that you have n cities, you have m roads. You can choose normal bike, super bike to move, but you can choose super bike only on one road. Rest you have to move by
Okay.
normal bike, right? So let
Okay.
me quickly share you one input example,
Okay.
right? So
Sure.
so this is your input. N is the number of city, M is the
Mm-hmm.
number of roads. The input are given, four inputs are given. So 1 to 2 is connection between cities. So first input and second input is the connection between the cities. 4 is the speed of normal bike, and 1 is the speed of super bike. Like, sorry, 4 is the time taken by the normal bike, and 1 is
Mm-hmm.
the time taken by the super bike. So you have 4 inputs. The first input tells you the first city, second input tells you the second city. So there will be a connection between first city and second city. The next two
Okay.
inputs are, the first input is what is the speed of, like what will be the time taken to go from city 1 to city 2 if you use normal bike. The
Mm-hmm.
fourth input is like what will be the time if you go by super bike from city 1 to city 2. Respectively,
Okay.
there are 6 roads, so you are given 6 roads information, and for each information you are given, like the road is connecting to which city, and also what will be the time taken if you take a normal bike, and what will be the time taken if you take a super bike.
Okay. Uh,
Yeah,
okay. Let me just draw this. Maybe let me just draw this a bit.
sure.
I think that will make more sense somehow. I'm
So
not
are
sure.
you drawing somewhere? You can share your screen if you want, or yeah,
No, no, no.
not an
I'm
issue.
I'm not drawing. I'll draw here only,
Okay,
but
okay,
I
sure,
just
sure.
gave an extra space somewhere. I just figured it out. Yeah. Okay. Yes. So we have this one. One is connected to two, right? And one is connected to two. Two is connected to four. Okay. Two is connected to four, and four is connected to six. Okay. Four is connected to six. Maybe it's better if we give two a few more spaces. One is connected to two. Two is connected to four. Uh, four is connected to six. Hmm. Okay. Let's see. Okay. There is another route, I believe. One is connected to two. Two is connected to four. Four is connected to six. One is connected to three. Okay. I don't know how to draw this, but yeah,
Yeah,
let me try.
that will work. That will work. You can just give a dash. Yeah.
One is connected to. How do I get a up arrow? B maybe.
Yeah,
One
yeah.
is connected to. Tough. One is connected to three. Three is connected to. Three is connected to. V here. Sorry, V small v. Three is connected to what? Five. Five is connected to six. Okay. Five is connected to six. Now it basically like kind of diagonally goes. So I'll just maybe draw a few. Five is connected to this six that we have here. Or maybe I could have just drawn here itself.
Yeah, yeah.
Three
You
is
could have drawn
connected
5
to
at the side. Yeah, that would make better sense. Yeah.
three will be connected to five, and five will be connected to six. Let's just assume that it goes up,
Yeah,
right?
yeah, yeah, yeah. Got
It
it.
will be connected to six. So if I write the weights down, 4 to 1. So for the first one, it is 4 comma 1 with superbike, it's 1. After that, 2, 4, it's 10, 2. And we have here 3, 1. 4 to 6 is 3, 1. Okay. We have 3, 1 here. Okay. It doesn't actually look very good. Once again, let me just make a bracket.
Yeah, then it will be more readable, right?
Yes, yes, yes. So 2 and 3, 1. Okay. Next we come here. 1 to 3 has weight is 2, 1. So we'll have 2, 1 here. 3 to 5. 3 to 5, what is there? 6, 4.
6,
Okay,
4,
6, 4. And 5 to 6, it will be what? It will be 5, 4.
5.
Okay. So if we see now, let's go from 1 to 6. Source is 1, destination is 6, I believe.
Yes.
So 1 to 6, what is the age weights? Okay, so if I take 4, like let's just travel normally, like using a normal bike. So 4 plus 10, that is 14, plus 3, that is 17. I get a weight of 17 if I reach 6, like taking normal bikes. If I take if I take normal bikes on the other route, I have 2 plus 6 will be 8 plus 5, 13, right? So definitely the second route seems more favorable, but we have another condition here, that is we can use a superbike at max once, right?
Yes.
So I see that maximum cost incurred here is by this road, right? So by this road, the maximum cost is getting incurred. So why don't I take a superbike here? So I have 4 here, 4 plus 2, because I take a superbike, so 6. 6 plus 3, it will be 9. And if I take a superbike here somewhere, so maximum cost is by 6, right? So I'll maybe take 4 here. So 2 plus 4, that is 6, plus 4, 2 plus 4 is 6, plus 4 is plus 5 is 11. So definitely I'm getting a weight of 9, like a total path of 9 units. So that's, I think, the answer, right?
Yeah.
That's the answer to this.
Yeah, exactly. So if you use just if you just use the normal bike, the first road seems lengthier than the second road. But if you take that option of using the super bike at max once, then you find that if you use it 2 instead of a 10, you get the answer as 9, and the first path becomes more preferable than the second part.
Okay.
So your
Got it.
answer
Yes.
becomes 9 here, and make sure that you use the super bike only once. You are not allowed to use it any more than one time. And yeah, you can think about the solution.
Okay, definitely. So definitely, when it comes to graphs and when it comes to like weights and minimum path, definitely I'll think about graphs. This is a definitely graph problem where I have to find the minimum distance from source to destination. So Dijkstra is what I'm looking into right now. So because it's a weighted graph, so definitely Dijkstra. But the problem is, what I was thinking is maybe what matters because I am getting a
one second, so I'm like, sorry to cut you off. Like, why did you think like Dijkstra will work here? Like any
okay. Because it's a graph problem, right? Like we have to travel from a source to destination, so it's a single source, shortest path. What I'm looking into, and because we are talking about shortest path, but let's just forget about super bikes for now. We just have normal bikes. So now it is basically a single source shortest path on a weighted graph, which is basically what Dijkstra solves, right? So that's why I was thinking, but I have one super bike, right? I have one super bike here, so it won't be like very trivial. I don't think it's very trivial. What I was thinking right now is, if we see here 10 to 2, right? Maybe this because this change is taking a maximum effect, like 10 minus 2 is the best thing we can do. Like out of all such moves, like 4 to 1, that will give a difference of 3. Like we can improve our answer by only 3. 10 to 2, we can improve our answer by 8. 3 to 1, we can improve our answer by 2. 2 to 1, we can improve our answer by 1. 6 to 4, again 2. 5 to 4, again 1, right? So I see that 10 to 2 is what like it's the answer. Like I can reduce the answer mostly by 10 to 2. That's what I was thinking, but again, like there's a problem. Like what if 10 to 2 is not at all in the path, right? Like there might be another better path that actually doesn't even cover 10 to 2. Like I could have another like route completely that actually takes a weight total weight less than 9, let's say. So in that case, if I just reduce this to 10 to 2, that doesn't make sense. Now, what I can do is I can maybe find the path first, and then, but again, like that will not work here only, because
Yeah.
if I find the first path, it will just go through this route, and in this route it will like try to optimize, but again my route is completely changing if I just take one super bike.
Yes.
So that's
You cannot just go blindly select the shortest path. That will not help you, because you can see here
definitely.
only the shortest path does not help. Once you change, the second shortest path becomes the smaller one.
Mhm.
So
Makes sense. Okay, I think okay, so what I'm thinking here, maybe what we can do is so what does Dijkstra find? Let's just come to the basics again. What does Dijkstra find? Dijkstra finds for a given source what is the smallest path to any possible node, right, in the graph. That's what Dijkstra finds, right?
Yes.
For a given source, it can find the shortest path to any other node in the graph. It's not just a given a destination and a source, the shortest path to that destination. It can actually find to all possible destinations, all possible nodes, what is the shortest path from a given node. So that's what Dijkstra finds. So what I'm thinking here is that, what if I do a Dijkstra, right? I do a Dijkstra, but I don't do a normal Dijkstra, right? I definitely do a normal Dijkstra. I don't modify that much, but I do a Dijkstra from source. It will find the shortest path to all possible nodes. What I do is I also do a Dijkstra from destination, right? Because I can just treat the destination to be another source. So I do a Dijkstra from the destination. It also reaches all possible nodes that are there. All possible nodes that are there. So what has happened here? I've done a Dijkstra from source. It has, I get all the minimum weights to minimum weight paths to all other nodes that are possible. I've done a Dijkstra from destination. With that, I get from destination what is the minimum weight that I can get to for each of the nodes, right? Now, yes, that actually makes sense, because now I just can take one super bike, right? I can take one super bike, so I have to decide on which edge I want to use the super bike. What I can do is, see, this actually becomes interesting. What I can do here is, say I'm using it on some edge U to V. I'm using a super bike on some edge U to V. In that case, I should take the normal bike and travel till U. I'm taking some, let's say U to V, right? This is the edge on which I'm taking the super bike. So definitely, let's say this is the source, right? This is the source, let's say. Okay. This is the source. Definitely, I should travel from source to U using normal paths. Then U to V, I'll take the special path, right? I'll take the special path from U to V. And again, from V to destination, I should take normal paths.
Makes
right?
sense.
I should take normal paths. Is it making sense?
Yes,
like
yes.
What
It is making sense actually. Yeah.
Okay. So H to U, I have already found what is the minimum cost from H to U, right? Because I've already done a Dijkstra from the source. And I know this minimum value. Let's call this minimum value to be some X1.
Cool.
From B to D, I also know this value because I have already done a Dijkstra from destination as well. So from destination, I know the minimum path, minimum length path to V. So let's call this X2, right? I know this. Now here I just take a super bike. Let's call it S. My answer for this change will be X1 plus S plus X2.
Cool.
So I will try to do this for all possible edges, right? Because I can use the super bike at max once. So if I do it for all possible edges, that actually solves the purpose, right? Because I cannot have any more super bikes, only once. So all possible edges, I'll just try to use the super bike there. And I can just use this like formula to find it, X1 plus S plus X2, and that will actually give me the answer.
Okay, so you're going to iterate over all the edges and do this particular thing, like from source to this particular node, use superbike for that particular edge, and then from the next node till the destination, you already have pre-calculated it, right? And if you do the minimum over all this, you get the answer. If I'm not
exactly wrong. Yes. And also, like, I have to include the normal path from H to D if I don't take a super bike at all.
Yes.
So that's also
that can also be a possible solution. Yes.
Okay. Shall I write the code?
Yeah, sure. Go ahead. It looks perfect solution to me.
Okay.
Like people in the chat, are you understanding what he is trying to suggest? Let me know in the chats, right?
I'll just maybe create a class for Dijkstra, like just to make the Dijkstra calculation easier.
Sure, sure.
What do I need in Dijkstra? I need a graph. Definitely, I need a graph. So vector int graph. Let's call it G, and I'll take a const here as well. Const int n equals to, let's say, how many edges did you mention? The number of
Yeah, you can
nodes that are
consider
there?
all as 10 to the power 5. Number of edges and
Okay,
number of nodes.
everything. Oh, everything is 10 to the power 5. That's perfectly fine. So constant n will be int 1e5 plus 5, and vector int, I'll just create a graph gn. And for Dijkstra, I would also, yeah, I'll also create a distance, minimum distance. Let's call it d, d of n, minimum distance for a given source, right? I will also store n number of nodes that are there. So let's come to the constructor now. Let's come to the public section for this. So public, and here should be a semicolon as well. Yes, public and Dijkstra. Dijkstra n, it will take in n as input. Let's call it capital N, and it will just, oh, I cannot call it capital N as well. Let's call it num nodes. I'll just initialize n with num nodes. N equals to num nodes, right? N equals to num node. I'll also add, like, this is not just Dijkstra, maybe this is also like for creating the graph as well. But yeah, like void add with edge. Void add edge. So it will take in two things, u and v, and it will add a edge, right? So it will take u and v, and also like definitely weights will be there. So int weight 1, int weight 2, right? So weight 1, weight 2. But we also need to store it somewhere else, because we have to iterate on all possible edges, right? So we have to store it somewhere definitely. So let's store it in a vector as well. Vector, it will be what? Vector will be a pair of int that won't work as well. Wait, this will become a bit complicated. So let me just create a different class altogether for node, or a structure maybe. So type def, I'll just type def struct node, or sorry, it will be edge, right? It will be a edge. So edge, what will it contain? It will contain UV, W1 and W2. UV, W1 and W2. Let's call this edge. Okay. I'll create two constructors here quickly. So struct edge. I'll just create a default one that will just maybe initialize everything with. Sorry. Yes. Default one will be u equals to v equals to w1 equals to w2 equals to 0. Everything is 0 initially. I'll create a parameterized as well. So it will take capital U, capital V, W1. W1 is the weight of the normal bike.
Yeah.
W2 is the super bike.
Makes sense.
Okay. So U equals to U, V equals to V, W1 equals to W1, and W2 equals to W2. All right. We have this. I'll create a edge, right? So it will be edges, multiple edges will be there. So let me create a vector one, a vector of edge. Let's call it edges, right? Vector of edges. Now I'm given num nodes and num edges here itself. Num edges. Also let me take in m as well as a data member here. So n equals to num nodes, m equals to num edges, and what else is there? I have to create an array, right? I have to create this vector edge. So edges equals to vector edge of size m and 0. Size m initially. Let's keep it m of size m. We just allocate the space initially only, right? Now I'm adding an edge w. So ages of, sorry, I don't actually add it here itself. What I'll do here, instead of, I'll just push back on this, right?
Yeah,
So
that makes better sense, right?
yeah. So ages dot pushback. I'll push back a age. I'll create a age here with UVW1 W2. UVW1 W2. Also, I need my normal graph. So I definitely need the when I do Dijkstra, I just need the weight, right? The normal bike weight. So I don't care about the super bike right now. So I'll just take a pair in here, right? So G of U dot pushback VW1 and graph of V. I'm just creating the adjacency list here. Pushback U W1. Okay. So I've added the age as well. Let me just look into this once. I think that should be fine. Okay. Let's just do Dijkstra, right? Void Dijkstra. Void Dijkstra. And one more helper method will be there. That is get weight. Int get weight. And here I'm given a node S. I have to get the corresponding weight, minimum weight. So I should just return D of S. The minimum weight basically, return D of S. So void Dijkstra, I'm given a source here. I'll have to do a Dijkstra, right? So first of all, fill D plus N. That is, I'll just maybe initialize everything with 0 or infinity rather, because infinity as in I'll just take it as int max.
Int max, yeah.
So D of SRC will be equal to 0 initially, and we'll also take what will it take? We'll also take a place to store these things. So maybe a set. So set pair int. Sorry. Set pair. So I'll be using a set to do that extra. Set pair int, and let's call it PQ. So PQ dot insert. I'll insert initially to this 0, SRC. That's my starting point. Okay. Okay. Now while I'll do the normal Dijkstra code, while not PQ dot empty. While not PQ dot empty, V equals or auto, or you can take a pair as well. Let's take a pair. Anyways, pair int. We take the first element out, like the minimum element out. So TP equals to PQ dot first, or sorry, PQ dot begin, and we'll take the value at that position. So we take the value at operator and PQ dot begin. Now what we'll do is this is fine. This is done. Now if also we have to erase that. So PQ dot erase, that should not be any longer in the in the set. So PQ dot begin. So let's take the node here. Int U equals to PQ dot second. In the second element we have the node, and the distance is we don't need the distance for now. So for int V will move through the adjacency list. Rather, it's a pair int, right? Pair int V belongs to the adjacency list of U. Move through the adjacency list one by one. If V dot okay, I'll compare the whatever V dot first. If the distance found till now for V dot first is greater than the distance I'm discovering right now, that is D of U dot first, D of U plus V dot second, the age weight. That is, I'll travel to U, whatever is the minimum distance till U, that is stored in D of U. D of U plus V dot second, right? D of U plus V dot second. That is the new path I'm generating. If this weight is greater than that, I'll just set D of V dot pq dot erase. I'll just erase d of v dot first. Sorry, I'll just make it a pair as well. So make it a pair d of v dot first, d of v dot first and v dot v dot first.
Do we need to erase? Like, have you inserted anything prior to this? I don't think so.
Yes, we'll be inserting next, right? We'll be inserting here only. Like we'll insert with the new weight basically. So that the old weight, if it is inserted already, it should be erased.
Okay, got it.
If
Like,
it has
one
been
thing you
found.
can do, like erase may like if the value is already not present, so you can check once before erasing.
But it doesn't show an error, right?
Okay,
No,
okay. Then
definitely
it's all fine. Then it's all fine. Yeah.
it doesn't show an error. So that's an advantage of C++. But definitely, that check should be done ideally. So d of v dot first, I insert with d of v dot first and v dot first. And I update my current weight definitely. I update my current weight. D of v dot first is equals to d of u plus v dot second. So I update the current weight. So this is the Dijkstra code that I have. Dijkstra is done. Now I'm also getting this d of s. So I think most of the things are done, set up, like they are set up properly.
Yep.
Now all I have to do is write the method, right? So int get mean path weight. So not get mean path weight. One more thing that I maybe need to do is, okay, I might actually, I don't need to maybe store this here, the edges here. But actually, I have delegated a lot of tasks here. So 1 second, let me just
I get the logic. Like for the graph, you could have done it separately, a separate class.
Sorry,
Yeah, I'm saying that I got your approach. Like for graph,
definitely yes.
You would be making a separate class as well, and for Dijkstra, you are making a separate class because you don't need to call the same thing twice.
Right, exactly. And in Dijkstra, I'll be passing, whenever I do this, I'll be passing, for the graph, I'll be passing maybe a reference to this graph class, like the graph that we have. So that the graph can be delegated out completely.
I got your point. Like you can code it out. I got your point. You no need to change it.
Okay. I need to probably, but let me just see if it can be done in some good way. Okay. I think I have to move it to this. There's nothing that I can do here. Sorry. I'll just do this here only. So, or I think graph. Yes, I think I have to do this. So d of I have to take it here. D. So let's have this, or what we can do here, we can definitely take a vector in D and have the vector in D, and we'll create the constructor Dijkstra. Constructor, it will be in public section. So let's create the public section here and Dijkstra. I think we have taken a lot of time because of this, but yeah, let's try to code completely. Also, we have to have a graph reference. So graph G, let's call it graph G. So we'll pass here a reference to the graph ampersand G1, and also and vector. I'll pass in here n as well, number of nodes. So D equals to vector in n plus 1, and initially let's just initialize to int max, right? We don't have to like then take care of that later on. And G equals to G1. Let's just do that, and I'll just copy the code for
Dijkstra below and put it there.
Yes, this one, this part I'll just completely copy it out, and I'll put it somewhere here. So I think I don't need to do this. This is fine. And void do Dijkstra, let's call it maybe compute mean paths, and Yeah, I think here only G should change. So G of what should change? G dot G of U. So it should be G dot G of U. That is the only part should change. I think. But yeah, like definitely remaining things. It should be graph. It should be graph and yes. I think this looks good.
Yeah.
So I have to maybe compute one more thing that is okay. I can actually compute that.
Inside the get min
I
path
think I can
only.
keep this in public. I just want to keep this in public section, the edges,
Cool.
so that I can access them from the main method. I'll just keep this in public section. So get min path to destination, and will be given a source. I'm believing we'll be given a source. Will be given a destination. So I have assumed that I'm just assuming that these things are populated already.
No,
I'll be
sure.
working on the core functionality only, right? I think that's clear. Okay. Okay, so let's just go in source and in destination. Everything is populated. Everything is working. Like yeah, ages are added and those things.
Yeah,
So
sure.
I'll create a Dijkstruct object Dijkstra d1 equals to Dijkstra. I'll be passing here what? I'll be passing here the graph. So let's say I'm getting the graph component here, graph and G. I'm getting the graph component here. So I'll pass in G and I'll pass in N as well. That is G dot N. I'll be passing in here. And again, I'll do Dijkstra d2 equals to Dijkstra. I'll create two Dijkstra components because one for source, one for destination. And d1 dot do what was that? Let me just remember this once. I'll see this once. Compute min path.
Compute
right?
min path, yeah.
So I'll just do compute. Yes, I'll just do this. So d dot compute min paths. I'll start from source, and I'll again do d2 dot compute min paths. I'll start from destination. And I think we are done almost. So our answer is equals to 0. So answer is definitely we'll initialize this to d1 dot. We have the min path or something. D1 dot get weight. D1 dot get weight.
Yep.
So we'll be just using this d1 dot get weight with source and with destination. And we'll see whatever is the minimum path. Otherwise, we'll travel on all the edges. So edge E belong to G dot what was that? Edges, right? G dot edges. Yes. So G dot edges. I'll go through all the edges, and I can take a reference here. Definitely, I can take a reference here, and all the edges, and I'll just do answer equals to mean answer, and what do we have? We have d1 dot okay, first of all let's just break it down a bit. Int u equals to e dot u, int v equals to e dot v, int w2 is equals to e dot w2, right? So mean of d1 dot get weight up to u we will be going, plus we'll add w2, plus we'll add d2 dot get weight up to v. So that should be it. And also we should do the reverse way around, other way around as well. Mean of answer d1 dot get weight v will find up to v plus w2 like u to v plus w2 plus d2 dot get weight up to u.
Yep.
So I think that should be it. And yes, and return answer. Yeah, I think that should be the code. Code for this.
Works perfectly. Like you have covered the edge cases pretty well. Like I was going to point it out, but you found it out yourself. And yeah, the code is like crystal clear. Like anyone who goes through your code will understand the code in one go. and like it's very good to see like anyone coding it live here in front of audience like this. Like I'm very happy with the code you have written. Yeah.
Thanks.
So yeah, like I was struggling with writing the segmentary code, but yeah, you have done it very nicely. Like the Digexa one, like you have separated all the components, like you have made the code as modular as possible. Like you have a graph class differently, you have a Digexa class differently, and you are just reusing the components again, which shows a very good sign actually. So with this, yeah, you have been able to solve both the problems, and I think you did better than me. But I will leave people in the chats to decide who won over the interview duel, or can we call it up a tie. Apart from this, let's quickly discuss both the problems, and then I can give a little bit feedback. Like I don't have any feedback to give because you have done exceptionally well, but still. So the first problem was like you have to find the shortest substring having distinct characters, right? So you have to find the shortest substring distinct you having distinct characters. What Soham has done is, first he found out that at what length should he get the ideal, like what should be the ideal answer at what length. So after that, if he increases the size of the substring, automatically the answer will be true for each of them. So first, to find that ideal spot, he is using the binary search, and to calculate whether that point is an ideal spot, he is doing a sliding window approach. So the prerequisite for this question was you need to know binary search and sliding window. Obviously, you can use a different approach, like you can just use sliding window technique or two pointer technique. That will also work. But yeah, the concept was very good to use binary search as well as sliding window, and I like the approach. The second approach, like the second question was bit tricky. You have NCTs, you have M roads, you have connections, and in that connection you are given two kind of weights. One weight which will be a little bit more, and one weight which will be lesser, and you can pick that less weight only once. And to do this, he has thought of a beautiful approach where he will be doing a source to destination and from destination to source. So he is doing a two-way Dijkstra. So Dijkstra gives you a single source multiple destination answer. So from starting from a single point, he has started from the source and he got the shortest path to all the nodes. And starting from the destination, he got the what to say? He got the shortest path to all the nodes, right? Now if you think, you have the shortest path to X, and you have, suppose U and V is the node in which you want to take the superbike. So you can get the shortest path from source to U superbike for UV, and get the shortest path from V to D, like V to destination. So this he has done for all the nodes, and finally the minimum of them he is returning. So yeah, this was the two problems. I thought I will be able to stop him, but I could not. Well done, Soham. Like you have done exceptionally well. I like the way you have approached the problem, how we have discussed the problem, and the most beautiful thing I found is that you have written the code very nicely. Like you have used the naming convention very nicely. Like everything is camel cased, and everything makes sense. Like whatever you're like anyone who is just looking the code, he can figure out like what you are doing, what you are trying to understand. So yeah, like it's a very positive feedback from my side. I don't actually find any negatives to tell you. So you are doing exceptionally well.
Thanks a lot. That really means a lot. Thanks.
Yeah. So with this, we are going to end the stream. We are actually we have 3 minutes time. So anything you want to ask to me and Soham, the chat window is all yours, audience. You have 3 to 4 minutes of time. You can ask anything you want to me or Soham, and we will be answering your any doubt. It's kind of 3 to 4 minutes AMA session. And then we can meet again tomorrow in my AMA session, where I'll be doing a resume review for you guys, right? So
And yes,
yeah.
I'll also be teaching about STL, so do join that as well.
Yeah. So Soham will be teaching about STL tomorrow. Make sure that you join his stream and learn STL from scratch. Like you can see the coding ability, and I'm pretty sure that he will teach you awesome. And after you go through his STL session, you can come to my session and look, like get your resume reviewed. I will review your resume. I will tell you what all things you need to add to get to a top tech company, what all things you should remove from your resume, and what editor or what tool I have used to create my own resume. This all I will go through tomorrow. But for now, you have the chat window open. If you have any question, you can ask, and within 2 minutes, we both guys will be leaving, right?
Yeah. Please do ask some questions.
So
I would really like to get
yeah,
some.
so we have first question. What about DFS plus max heap?
Okay. DFS plus max heap. how can you do a DFS and a maxip, like
So
it's a
for
graph,
Maxip,
right?
like yeah, Digextra he has done using set, but we can also do the Digextra using priority queue. So I prefer it using priority queue, but yeah, set is also fine. Set is very nice to implement actually, but yeah, we can do it using your Maxip. But I am not quite sure like how DFS, that I have to think. Like any hints, Soham, that you want to give them?
Um, I'm not sure. I don't think DFS should work because like it's a graph problem where you have to find shortest path to a destination. It's pretty standard Dijkstra. Otherwise, like there would have been some DFS solution. I'm not sure. Like I'm not sure
Yeah.
about if we have some DFS solution for shortest paths as well.
Yeah, so see, any problem can be solved using DFS. Graph problem can be solved using DFS, right? But depends on the complexity. Like we have a full-fledged algorithm written for it. So why to spend much time on DFS, right? So interviews means time. If you know something, make sure that you utilize it. Don't waste time on something, or you may miss some subsequent questions, right? So let's move to the next question. Is CP? I think you want. Okay, is CP necessary to crack interview? Like I will not say yes altogether. It's partially true, but yeah, CP will actually help you to understand the logic building ability. Seeing a new question, you'll understand how to approach a problem, how to solve the problem, how to write modular code, and that is what is necessary for your software engineering field, right? So this is what we can think about. कब तक होगा sir?
I'll
Yeah, anything, Soham? Yes.
Yes, I'll take Pratim's question. Like he's asking that I think like the same thing that I actually asked. Like I thought of if we store the normal bike travel time and then we like get rid of the maximum value that's there. But again, like if we see like the first path that we get is 1, 3, 5, 6, and in that if you remove the maximum time that is 6, you will remove it to 4. So it will be 2 plus 4 plus 5. That is not the answer, right? So the path is altogether changing by just changing one edge. So we cannot.
Yeah. Yeah, so basically you cannot just change the max time, because it may happen that you are not using that path altogether, right? So it may happen, right?
Mhm.
कब तक class होगा sir? That is like or 2-3 minutes I think, and we leave. When we
Uh,
reach the destination through DFS, we know the max value of normal time minus superbike time from the max heap, so we can minimize the value from the total time. See, a problem can be solved by various solution. Your solution might be correct, right? So you can test it out on some test cases and try to look like whether it will work or not.
No, I don't think DFS will work because I'll just give an example here. DFS always visits the first route that is obtained, right? It doesn't visit all the routes. It will just visit the first route, and after that, you will be marking the visited equals to true, right? Visited array to be true. So you will never revisit that same node again. So whatever is the first node that you are discovering, that is when you stop the DFS. So that actually doesn't work in fine. So like there might be a path. Like let's say I first visited 3 instead of visiting 2. I first visited 3. That's the order in which it's there in the tree, in the graph. So I would just visit this path. I would never visit 1, 2, 4, 6 this path, right? So that's why we definitely, if we are going through all possible paths, that will be a backtracking solution and it will be exponential. But again, with simple DFS, I don't think we can do them.
Yeah, like
Yes,
that. The complexity comes into picture, right?
definitely yes.
Hmm. So backtracking will take your exponential time. Like you can go through all the nodes and come and again go through all the nodes, but yeah, that will take exponential time. And for that reason, we have Digester, right? We have that tool only to get the shortest path. Yeah. So with this, we are almost 3 minutes more than the scheduled time. So yeah, I'll
Mhm.
be closing the stream. Thanks Soham for joining first of all, and thank you everyone for
Thank
watching.
you as well.
Thank you everyone for
Thanks to you.
watching. Make sure that you join the tomorrow stream where I'll be doing resume review, and also make sure that you join Soham stream where we'll be learning many things about STL. With this, we are ending the stream for today. I hope you all enjoyed our interview duel. Like both of us were able to solve the problem, but yeah, let's see if we can
Sure.
take more duels later on where I can bring on more harder problems to stop Soham from solving, right?
Provided we have, but not in this channel, definitely.
Yeah, let's see if we can. So with this, we are ending the stream. Thank you all for joining. See you soon again.